Hello, this is Christian from the Never Engine Labs. I'm just going to make a short video to introduce the new addition to our suite of custom-made classes for recording and playing spectra. This one is called Spectral Panning Strategies. This is all for Kima 7, of course. The spectral panning strategies is derived from some work that we were carrying out at the complexity lab, where distribution ways of distributing different voices in an abstract way. It could be panning, it could be any other type of distribution. And Gustav has been, well, they're originally written in Capitalk, and Gustav has been working hard to bring them into highly efficient sample rate code. So here we have a module that is our first prototype for allowing you to distribute a mono spectral analysis into stereo using two resynthesis banks and this module, which will be defining the distribution coming out to the left and the right. Like all our modules, they contain a description or instructions, if you like. Here within the class, you just have to pull down the description and you'll be able to read some guidelines we've put in there about what the parameters mean. And here we talk about this strategy. So they are 16 fixed distribution algorithms. They are sort of kind of preset at the moment, and you can choose between them just by entering an integer here. This is the number of partials that you will be distributing. It can be different to your partial count elsewhere, or your frame size, as we also call it. That means the number of partials or the number of frames. It can be different. It's internally adjusted. And we've also included the option to switch off the dynamic strategies, which are here. You'll see them in a second. Because they use up a lot of DSPs. Maybe if you're not using them, it might be more efficient to switch them off, especially if you're using high partial counts like 256 or upwards. Okay, so far we've tested dynamic panning with 256 on a pack at 44.1. Seems to be good for now, but you can always reduce the processor load with that option. So let's take a look. Here's a kind of example of how you would build this. This sound is included in the Spectral Lab update that we'll be publishing today, so you can explore it there. The panning strategy sound needs to receive only the amps leg of the spectrum. It will work only with amps, not with frequencies. So you split it first here using the amps only, and then I've just in this sound I've just set up some visualizers so you can have a look at it in the VCS. But once it's gone through the panning strategies, you then take the left output of it and synthesize with one bank, and the right output from it and synthesize with another bank of oscillators. Join them together and you'll have this stereo image. So let's have a look at the VCS. Here you can see the idea in practice. This is a linear spread, which is simply taking partial 1 and taking partial 2 and distributing them in a linear way. This is a shuffled spread, which will be different every time. It's shuffling the it's putting each partial in a unique random position. This is a spiral spread. I call it spiral because the lower partials are kept quite central, and then the panning width opens up as it goes up towards the higher spectrum. So you get a kind of more airy stereo spread at the top and less stereo spread at the bottom, which is where your bass normally is, which you actually don't really want to have that too wide. Here's a sort of opposite sine kind of spread, which is quite interesting. This is a very wide, odd, even spread. Just forces all of them to the left or the right according to whether they are odd or even partial numbers. This is a prime sieve spread, which is quite experimental, but it distributes according to whether the partial number is a prime or not. Here's a double helix spiral spread, which also the lower partials are quite centered, but then they start to get wide, but then they center again, and then they widen up again. This is something similar, variation on the double helix spread. Here's a static. This is the golden ratio spread, which is rounding towards the nearest multiple of the golden ratio. It's quite similar to the linear spread, but subtly different. These have all been fine-tuned by listening. You can hear it on the cans, I think, quite clearly what's going on. The width is also fully adjustable. If things are too wide, you can bring it in. So here's the dynamic strategies. This one's quite springy, a kind of swarmy physical model sort of thing. Here's an interesting rhythmic algorithm expressed in this spectral domain. Quite interesting. This is a snaking random walk, which, as you can see, the lower partials don't walk as far as the higher ones. This is similar, but almost inverted the other way. A different rhythm to it. This is a sort of stroboscopic spectral panning algorithm. Twisting ribbon, which resembles a ribbon twisting up through the partial bands. Also this kind of scanning ripple through the stereo field. And here a spinning spiral where the higher partials are spinning a lot more and the bottom partials are fixed. It's almost a kind of a tornado or cyclone kind of shape. As I showed earlier, if things are too wide, you can always just bring it in. Yeah, so we'll be adding more strategies in further updates, and we'll also be adding control, so you can perhaps adjust the speed that they move at and so on. But it's quite an exciting update, and we hope you enjoy it. Of course, we're always there on the Slack channels. If you have any questions or you want to be guided along how to implement this stuff in your sounds, Gustav and I are there to help you out, of course. Thanks a lot.